Good morning. This is your Stats Sensei, Mr. Spensey, and this is Death Packet 11, questions 11 through 20. A bag contains chips of which 27.5% are blue. A random sample of 5 chips will be selected one at a time and with replacement. What are the mean and standard deviation of the sampling distributions of the sample proportion of blue chips from the samples of um, size 5? All right. So, first off, they're asking for the distribution of the sample proportion. Distribution of the sample proportion is this. P hat equals P, and our standard deviation of P hat will equal to P times 1 minus P over N. So let's take that 27.5% divided by 100, and we end up getting 0.275. So everywhere we have a P, we need to replace it with a 0.275. Well, when I do that, and also just based on the formulas, we know it can't be A or B or D. So now we're down to C and E. All right. Well, 0.275 is right here in the standard deviation, 0.275. 1 minus 0.275 gives me this value divided by the square root of 5. We cannot use the whole values. That's what's wrong with this. These values needed to be divided by 100 because this was a percent. So please make sure you divide your percents by 100. 12. A recent report indicated that 90% of adults in a certain region actively try to include vegetables in their diet. A simulation was conducted that consisted of 50 trials with a population parameter of 0.9. Okay, so they're just telling us what I just wrote down, which is P is 0.9. Each trial consisted of a sample of size 10. All right. The number of successes out of 10 was recorded where successes represented an adult trying to eat a vegetable in their diet. 5 possible simulation results are shown below, which is correct. Okay, well, first off, we have to be centered. If we have a sample size 9, our expected value is going to be NP. So we need to be N times, because our sample size is 10. So we need to be centered at 9. 9 times, excuse me, 0.9 times 10. So we need to be centered at 9. All right. Well, that gets rid of B. That gets rid of C. D, please make sure that you're multiplying by the sample size, not by the trial size. All right. The trial size will have an impact on this problem, but not right here. So that gets rid of D. So we're really only looking at A and E. But I have 50 trials. This does not look like 50 dots to me. If I counted all those dots, which I'm not going to, I'm guessing, because both of these are centered on 9. That's good. But I need 50 trials, so I need 50 dots total. Well, I can look at this and go, that's definitely not 50 dots. So this must be the answer. That must be 50 dots. 50 results from the 50 trials. A sample of manufactured items will be selected from a large population in which 8% of the items are defective. All right. So we P equals 0.08. Of the following, which is the least value for a sample size that will allow for the sampling distribution of the sample proportion to be assumed approximately normal? Cool. So what they're saying is N times P has to be greater than 10. And also, the second part of that is N times 1 minus P has to be greater than or equal to 10. And that should have made it equal. So let's plug in. We know P is 0.08. So N times 0.08 greater than or equal to 10. Divide both sides by 0.08. 10 divided by 0.08, and we ended up with 125. So n equals 125. If I do the same thing over here, n times 1 minus 0.08, I have n times 0.92 greater than or equal to 10. Divide both sides by 0.92. And 10 divided by 0.92 equals 10.8, or about 11. So n has to be greater than or equal to 11. Well, we need to take the larger one. The larger one is 125. That's our answer. Most recent tests and calculations estimate at the 95% confidence level that the maternal ancestor to all living human beings called mitochondrial Eve lived 273,000 plus or minus 177,000 years ago. That's a lot of variation. What is meant by 95%? 95% means if we did this over and over again, we'd expect 95% of our confidence intervals to capture the true age. Or if we took all possible combinations, we'd be 95% confident that we've captured it. All right. So a confidence interval of the true age of Mike has been calculated. No. No, I'm quite confident that we didn't have the population standard deviation. So since we didn't have the population standard deviation, there's no way we could have done that. They only took samples, all right? And they had to be using samples. The confidence interval of the true age of mitochondrial Eve has been calculated using t-scores consistent with degrees of freedom of n minus 1 and tell probabilities of plus or minus 0.025. Maybe. There's a 95% probability. Oh, but they're asking for the confidence level. That's not the definition of confidence level. There's a 95% probability that mitochondrial Eve lived between 96,000 of 450,000 years ago. No. Remember, this is the in repeated sampling. So in repeated sampling, or if we sampled all, we'd be 95% sure it was there. If 20 random samples data are obtained by this method, a 95% interval is calculated from each, and the true age, no, that's not what it's done. Remember, it's in repeated sampling. We expect to capture the true population mean 95% of the time. Or if we ran all of them, all possible samples, 95% of them would contain it. 95% of all random samples obtained by this method will yield intervals that capture the true population mitochondrial E. So in other words, if you did it over and over again, 95% of your samples would capture it. Or if we did all of them, 95% of all of them would have captured them, which means 5% of them would not have. So our best answer is E. All right. Number 15. In a recent Zogby International survey, 11% of 10,000 Americans under 50 said they would be willing to implant a device in their brain to connect to the internet if it could be done safely. What is the margin of error at the 99% level? Well, let's write down our formula. Our formula is p hat plus or minus z star p hat times 1 minus p hat over n. All right? So this part right here represents our margin of error. So we need a couple things. First off, it can't be A because it doesn't include, it does not include Z star. Bye. This is not anywhere near the right formula. And let's go ahead and calculate Z star because that'll be easy to do. Second vars, inverse norm. And there's a couple ways to do this. I'm just going to put in 0.99 and leave it at center. All Z scores 0 and 1. So 2.575, 2.576. So that gets rid of this. That would have been a 95% interval. Now the question is, which one of these? Well, let's look at our formula. What we should be looking for is we have the 2.576. We just calculated that. We should have 0.11 times 1 minus 0.11 over 10,000 because that was the sample size. Well, the only one that has everything under the radical is E. And that 0.89 is 1 minus 0.11 equals the 0.89. In a simple random sample of 50 teenagers, 2/3 said they would rather text a friend than call. What is the 98% confidence interval for the proportion of teens who would rather text a friend than call? Well, remember, p hat plus or minus z star. P hat, 1 minus p hat over n. Well, first off, we know p hat's 2/3. Let's just look at our form. Let's just look at these answer choices. D and E can't be because this 50, this whole part would have to be underneath. So Doug can't be without doing any work at all. All right, let's go ahead and calculate Z star because this part is the same for all of them. We're happy with that. So let's calculate Z star. And by the way, P hat was 2/3. So everywhere we have a P hat, we need to replace it with a 2/3. And Z star, second vars, inverse norm, 0.98. And 2.326, 16 is B. 17. The margin of error in a confidence interval estimate using z-scores covers which of the following? All right. Margin of error. Nothing covers bias. All right. Error is due to undercoverage and non-response. That's the type of bias. Not. Error is due to sample standard deviations are as estimates. That's not why. Type 1 and type 2 errors have nothing to do with it. It's because we know every single sample will vary. And because we say every single sample will vary, we're pretty sure we're plus or minus 5%, plus or minus 3%, whatever that level is. In a survey funded by Burroughs Wellcome, 750 of 1,000 adult Americans say they didn't believe they could come down with a sexually transmitted disease. Construct a 95% confidence interval to estimate estimate of the proportion of adult Americans who don't believe they can contract an STD. Well, first off, P hat equals 750 over 1,000 equals 0.75. And our formula is P hat plus or minus Z star square root of P hat 1 minus P hat over N. Now I can show all that work or I can just speed through it on a calculator. I'm going to speed through it on a calculator. So second vars or stat test, dropping down to number 5, 1 proportion Z test. And I can just put in 750 divided by 1,000. It'll do it. Oh, I chose the wrong place. Stat test, not Z test. I need Z interval. Thank you. Number 7. And boy, you know what? I'm not going very well. Scrolling way down. There we go. Letter A, 1 proportion Z interval. Yay, we got there. So X was 750. N was 1,000. That was our sample size. And we wanted a 95%. So plug in 0.95, calculate. 0.72316 and 776. This one is our closest. 19. A worker's representative for a large factory believes that more than half the workers at the factory want the opportunity to work more overtime. Which of the following are the appropriate hypothesis? All right. First off, these are typos. This should have been 0.5, but whatever. We'll deal with that in a second. Anything that has p hat in it is wrong. It has to be the population proportion. So p equals, this should be 0.5, and it says more. More tells me I'm looking for a greater than, so the one with greater than is this one, although this really should have been HO P equals 0.50 and HA P is greater than 0.50. The decimal's in the wrong place. 20. A recent national survey indicates that 73% of respondents try to include locally grown foods in their diets. A 95% confidence interval for the proportion of all people in the country who try to include locally grown foods in their diets is given as 0.70 to 0.76. Assume all conditions for inference were met. Based on the confidence interval, which of the following claims is supported? Oh, right. So we have a couple things. We can say, and this is at the 95% confidence level. We can say that 95% confident that between 70 and 76% of the population want to eat locally grown food. But anything outside of that is unlikely. All right. So less than half of all people in the country tried to include locally grown food. No, we believe it's between 70 and 76. So that's false. Less than 70% of all people in the country. No. Less than 75% of the people in the country try to include locally grown foods. Looks like it's less than 76%. All right. Less than 80% of the people try to include locally grown foods. Yeah, that's true. That may be our best answer. At least 95% of all people in the country try to include locally grown foods. No, we're 95% confidence is between here, but this 80% is above this. So definitely less than 80% are trying to contain locally grown foods. Look at that ant. All right. Appreciate you watching and look forward to seeing you on the next one. Thank you.